Thank you for that, and welcome everyone, and especially thanks to everyone for coming to a security talk at a Python event. So I've got some depressing things to present, but hopefully I'll try and make it a little bit fun as well. So just quickly, a little bit about me. My name is Mackenzie, but I also go by Mac. I'm from Aotearoa, New Zealand, but now I live in the Netherlands, and I work for a French company in DevRel, and you can find me pretty much anywhere with the handles @AdvocateMac. And I'm also the host of a podcast called The Security Repo. My mum says it's great, so you should definitely check it out. It would be nice to have more than 2 views. No. Okay, so first of all, I'm going to be talking about secrets. What do I mean by secrets? This is probably familiar to everyone, but I'm really talking about API keys, digital authentication credentials, security certificates, credential pairs for databases, encryption keys, and anything that's really used to authenticate ourselves or allow us to ingest, decrypt, or post and send data. What's the key differentiator here is that these are made to be used from machine to machine. So humans aren't meant to type these in. These are meant to be used programmatically. But unfortunately, humans touch them a lot. And whenever humans touch something, there's a risk for exposure, which we'll talk about. So very quickly, how do we use these applications? I'm sure everyone's familiar with it, but let's say we're building an application, and our application does a thing specifically. Maybe it's a social platform, and our algorithm is what's special about it. But it also has to do other stuff. It has to authenticate users, it has to post on a database, it has to be able to process credit cards. So we offload a lot of that to different third-party services. So maybe we're using Okta as authentication, Algolia as a search function, so on and so forth. So our application becomes a collection of different services. These services leverage secrets to be able to communicate. As an attacker, as a security guy, every one of these icons, these logos, is some way that I can get into your systems. But then once we've built that, we need to host it somewhere. We need to host our code. We need to test our application. So now we have a lot of infrastructure we have to deal with. All of these communicate with secrets as well. Once we launch our application, then the pesky marketing team and sales team are going to want integrations into different areas. And again, more integrations. And we haven't even talked about the hundreds of microservices that we've probably built that we're communicating with that also leverage secrets. So very quickly, our applications end up into being these collections. So that's the kind of the recap of what it's. So hopefully we're all just on the same page here with what I'm going to be talking about. So one of the things we do at GitGuardian every year is we release this report called the State of Secret Sprawl. And basically, we look in public places to see how many of these secrets we can find. And then we release our findings. And I'm going to talk a little bit about this report, and I'm going to focus in on what we've found in relation specifically to Python codes. So you're probably all familiar with this site. This is GitHub, the largest code sharing platform on the world. If you want a collection of the most amount of source code ever, then GitHub is where you want to look. So just very quickly, I'm going to do a very quick demo here. Okay, so I have here a public GitHub repository. And I have here some AWS credentials. And I just have it in a file called config.py. And I'm going to do the biggest sin that you can do in programming, and that's commit credentials to a public GitHub repository. So we're going to make this. Now, the reason why I'm doing this is these credentials are what we call honey tokens. So what these credentials are going to do is they're going to alert me anytime someone tries to exploit them. Anytime an attacker tries to use them, I'm going to get a notification to say, here's the IP address, here's what they're trying to do. At the end of my talk, I'm going to show you how many people between now and then have tried to use those secrets. And I'll explain how they've found them. So hopefully the bad guys are up out of bed, ready to go. And well, otherwise it will be a little bit embarrassing, but I'm pretty confident. So just while we're talking about GitHub, how big is GitHub? It's very big. There was over 1 billion commits last year made publicly, just publicly. There was 85 million new repositories made, again, just publicly. And according to GitHub, there's 94 million developers using it. So this is an actual fire hose of information. And lots of weird stuff ends up on GitHub. Code that's meant to be private makes its way to the public repositories. It gets shared in different repositories. So you can find a lot of interesting things on GitHub. So what we did at GitGuardian is last year, we scanned every single one of those billion commits for secrets. So we scanned it for 350 different types of secrets. And then when we found the secrets, we validated them with the providers to make sure that they were actually valid and real credentials. So how many secrets did we find on GitHub? We found 10 million. 10 million secrets, which is about a 67% increase to last time. So these are secrets that are hard-coded or files like configuration files that have been included in public repositories that anyone can access. And so to give you an idea of numbers, 1 in 10 of the authors that pushed code publicly last year committed a secret. So that means that there's probably about 20 of, or maybe not 20, maybe 10 of you in here that pushed a secret last year according to these numbers. So it's not a problem that only affects a small group of people. It happens all the time, and it happens in kind of weird ways. But it's a fairly big problem. The number one place that we found secrets, anyone want to take a guess, is in the file extension .py. So app.py, config.py, anything like that. Now, this doesn't mean that Python developers are worse than everyone else, because you'd probably also know that Python's the most popular language on GitHub. Therefore, more code, more secrets. Makes sense. But it is showing that it's definitely a big problem. So it's not, if we look at some of the other files too, it's not just .py files that you might expose it. If you're using JSON or envs to manage your secrets, you could have a Python application and leak it with these file extensions as well. Lots of different files that we actually found. Just the .py, we found about 2.1 million secrets in just Python files. And there was about 1.3 million files that we found those secrets in. So again, this is an absolutely massive kind of scale of problems that we're talking about. What are the actual secrets that we typically find? So about 25%, 2.5 million were for data storage. So Amazon S3 buckets, could be managed databases. We also found about 2 million cloud provider keys. So what I just leaked on GitHub is for cloud providers. These are pretty scary because they're easy to validate. And as an attacker, yes, I can disrupt your infrastructure if you leak I can move in, I can do lots of nasty stuff. But even as a script kiddie, I can just do crypto mining on your accounts and rack up a huge bill for you. So you don't need to be very innovative to be able to figure out what you can do with a cloud provider key. Messaging systems is another one. We found huge amounts of things like Slack webhooks. And these are really interesting as an attacker because you may not think that they're that sensitive. But if I can post messages to your internal Slack channel, pretending to be you, saying you need to update your password, then that's a barrier of trust that a phishing campaign might not be able to get. So they can be quite sensitive, even if you don't really think that they are. And we've found a lot of personal projects where people were building Slack bots for their work. Maybe they get a notification when something goes down. They've been doing this on their personal kind of time, so it's ended up in their personal GitHub account, but it gives me access into your company through ways. So quite scary. The one I find funny is we found 3.8% of what we found were version control platform keys. So basically, we've found the keys to access your private code inside your public code, which was fun. We even found 500 commit messages where the message was your GitHub authentication credential. So it's kind of like you've sent an email and the subject is your password. That's kind of like the equivalent of what that is. What about Python specific? It's kind of hard because we find such a long list of different secrets for different services. But, Google API keys was number one. GitHub access tokens, AWS keys, lots of different kind of things in here. All right. So now I want to talk about how attackers actually do this. If I'm an attacker, I'm looking for these. I've just leaked credentials. I'm hopeful that someone's going to find them. But how does that person actually find those credentials? So there's lots of ways. This is the most obvious way, and one that's not that great, but I'll talk about it anyway. And that's just using the GitHub search functionality to be able to find files, right? So here I'm going, file name is credentials, and I'm looking for AWS access key. The search format is actually updated since I made these slides, but it's the same thing. Now you look for a path instead of a file name, but you get the idea. And there's lots of these that you can get called GitHub dorks where you can copy them and it's looking for sensitive stuff. This isn't that effective. One, you're going to have to sift through a lot of information. And two, what I want to stress, and I'm going to bring this up again later, is that when we're talking about Git, when we're working in Git, everything we do is version controlled. You leak a secret and remove it later, it's still in your history. So the GitHub search functionality doesn't look in your history, it just looks at the top layer. But the history is where you want to, it's really where you find secrets. So there's a much better way of finding secrets, particularly on GitHub, and that's abusing the GitHub API. So GitHub has a public events API. You just go to api.github.com/events. Anyone can do this, and you don't need any authentication. Now, what's scary about this is that this is a public ledger of everything that's happening on GitHub in real time. So everything that's happening, anyone can see on this ledger, and they can see your email address, who you are, and they can even find information about where you work. So they can monitor you. When we talk about things being public in GitHub, we understand that someone can go to and find our repository, right? We understand that. What we may not understand is it's actually being broadcast. All that information is being broadcast, and that's why the credentials that I just leaked are now in this ledger, and there's a bunch of bots and other things that are sifting through it and looking for them. And there's lots of events that are published in here, but the two that the attacker is going to be after is a public event. This is when a private repository goes public. Remember that it brings its history with it. So this is by far the most interesting. This is where you're going to get the best results. And then the push event is just when code is pushed. So these are the two ways that you can discover secrets. So does this actually happen? Are there breaches because of this? Yes. This is an example that happened last year. It's not a critical example, but it's interesting. Toyota, they have a mobile application called T-Connect. Kind of important. Can start your car. And what actually ended up happening is they were working with a contractor on this project, this T-Connect, had a Python backend. That contractor accidentally made their code public unknowingly. Inside that code was credentials for the database of all the users. Attackers, threat actors found it and were then able to launch phishing campaigns on everyone in that database because they knew they had a Toyota, so they could customize the campaigns and spam them that way. Luckily, security researcher also found it and alerted Toyota before anything too bad would happen. But this is just an example of when actual stuff does happen because you've leaked your keys. Now, the other area that I want to talk about is probably you're sitting there, okay, this is great, interesting, thanks, Mackenzie, but we don't have any public source code. Everything we do is private. I have no public source code whatsoever, not relevant for me. It doesn't matter because source code is really bad at staying private. It's an incredibly leaky asset. Think about everyone in your organization that has access to your source code. It's on their computers. It's probably backed up in different areas. It's inside your wikis, it's inside your documentation. So it's very prone to leaking. So if you're relying on just the authentication in your GitHub, then it's going to be very insecure. And last year, we saw lots and lots of secrets that were leaked publicly. Microsoft, NVIDIA, Samsung, Twitch, all of they had their source code, let's say, involuntarily open sourced, mostly by a threat group called Lapsus. They were purchasing credentials on the dark web. They were hiring insiders to gain access to this source code. So it wasn't a very sophisticated attack that they were doing, but the source code was able to make it online. So your source code is never an adequate place to store secrets ever in your history and that, because if it makes it public, then it's out there in the world, and threat actors are really targeting developers specifically. So we just take a look at one of these, Twitch. They had their source code leaked. There was 6,000 repositories that were made public. It was available on a torrent. It was made public because there was a misconfiguration in the Git system. They were managing their own Git server. They accidentally just made it public. It was only public for a few hours, less than a day, but still in that time someone managed to scrape all of it and publish it. We found 6,000 secrets inside that source code, including 194 AWS credentials. So pretty significant breach, and this isn't that bad. this is typical of what we'd find in a large company like this. So it's a real problem that's affecting a lot of people. Another breach here, I won't go too much into it, but Uber had some pretty bad ones. Essentially, if you know what a PAM system is, a privileged access management system, it's basically a secrets manager and a password manager rolled into one. If you don't want a threat actor to have access to anything, it's this. It's the most sensitive thing that you have because it creates accounts on all your services. They had hard-coded the credentials for the PAM account in a PowerShell script and version controlled it. This PowerShell script, what it did, when a new employee came, they ran this script to create them accounts on what they needed. So if as a developer, I'd create 100 accounts for all the tools that they needed. Because they had hard-coded that and version controlled it, it was in their Git history. A threat actor, again, associated with Lapsus, made it onto their repositories, found this credential, and was then able to create accounts for themselves and everything. Fortunately for Uber, they weren't very malicious. They were more after the clout. They were posting inappropriate things in the Slack channels, for example, when they got in there. They basically just wanted to say, hey, we hacked all of Uber. But Uber could have been shut down for multiple days because of this, had they wanted to. So just another quick example. Are people here familiar with Docker? I'm pretty sure, yep. I forgot where I was for a minute. Docker is another place we find lots and lots of credentials. I won't go too much into it, but basically we scanned tens of thousands of Docker images. We found that about 5% of them contained hard-coded credentials. A lot of these credentials were for things like package managers, but it means that we could poison your applications from this. So the secrets are not only just finding their way into version control systems of Git, it's also Docker. And I want to give you a quick example of a massive attack that happened because of this. So this is a company called CodeCov. Maybe you've heard of it. Personally, I like CodeCov. I think they're a great company, but they had a pretty significant breach. CodeCov is a code coverage tool. It tests how much of your application is being tested in the CI/CD pipeline. So it does a specific thing, not that critical, but important. The official Docker image for CodeCov had a leaked credential inside it. This credential allowed them to modify some code. So allowed them to modify the bash uploader script, which was being hosted in I think it was a Google drive somewhere. They poisoned that bash uploader script to do one thing. It said, whenever you're running CodeCov, I want you to dump all the environment variables and send it to me. So when your application is being tested, it needs to be built. So you need credentials to be able to do this. Hopefully, you've got test credentials, not production credentials. But you also have things like your GitHub access credentials. That's what the attackers were able to find. So they then poisoned CodeCov. Thanks to this, they had 20,000 users at the time, and the threat actors made it into the private source code repository of all of those companies. And there were big ones, Twilio, Monday.com, HashiCorp, all had their private source code accessed by threat actors because CodeCov leaked a credential and then that allowed them to poison it. I almost never pick on companies when they have breaches because frankly, I think it can happen to everyone. But I'm gonna pick on a company. So HashiCorp was part of this. So if you don't know what HashiCorp is a fantastic company, and they build, in my opinion, the best secrets manager available. HashiCorp Vault. Very heavy, but it does a lot of great things. They coined the term secret sprawl. Their whole thing is about keeping secrets outside of your source control. Because of this breach, they had to report that that the threat actors had found a secret in their source code and been able to use it. If HashiCorp has secrets in their source code, there is no hope for anyone else. So this just shows the scale of the problem that we have here. Other examples too, hard-coded credentials for a bank allowed them to access thousands of checks. I don't have time to go into it, so I'll just skip past, but secrets find their way into mobile applications as well. I've done research into mobile applications, and it's a terrifying place there. So let's get into why does this happen? All right, no one here is stupid enough to put a hard-coded credential in Git, right? No one here would do that. So the first thing, we need to talk about Git history and how this all works. Let's say, so in this we've got a feature branch in Git. I'm sure everyone knows what I'm talking about. I say to you, hey, here's some Algolia keys. I need you to connect to it and test. So as a developer, you go, oh, I'm just going to quickly check the connection works. I'm just going to pull some information. Cool, done. okay, I'll remove those credentials now, I'll put them as environment variables, or however we manage to do it. But you're just testing it. So they've removed the credentials, and let's say you get 100 commits down the path, it's time to have a code review and pull it into master. The reviewer, well, I don't know about you, but I'm not going to look at 100 commits at all the mistakes you've made to get to this point. I'm just interested in what you've done. So I'm going to compare that to my main branch, and I'm going to merge it in if all is good. There's a secret in there that's still in your version control history, but no one knows it's there. So this is one of the reasons why this is such a big problem. Other reasons are in logs and auto-generated files. You do a debug. You do a debug that's going to sometimes dump out your environment variables. There could be secrets in there. Git add all, because I'm lazy, and that's now in your Git repository as well. Not having .git ignores, this is one of the, in terms of like preventing them getting into Git, everyone should have a .git ignore file, please do. Putting secrets in the secrets.txt because it's a pain to get them, and then accidentally adding that. Secrets and template files, so when you create a Django project, the secret keys are in there if you don't remove them. Now Django's updated how they do that now. I think they say test credentials or something like that, so it's a little bit better. But that's just one example. There's plenty of things. If you connect to a Google service like Firebase, they're going to give you a downloadable file so you can get quickly moving. But unless you take a minute and handle those secrets properly, it's going to be an issue. And then just sharing them on Git. It's easy, right? There's only 10 people on the team. Let's just put them in. Let's put the env file in Git and be done with it. It's protected. So we see that a lot. We see everything. And then, of course, just hard coding credentials that we've talked about. So lots of reasons why this happens. Now, I don't have time to go into it, but this is where I get controversial from the other security guys because managing secrets is a level. Every security guy says you need to be on level 4. You need to be using Vault, dynamic secrets, auto-rotation, everything. And my argument is you need to do whatever you're actually going to use. So that might be using a Vault. If you're in a large company, that might be. If there's 5 of you working on an open source project, maybe encrypting them and putting it in Git is okay. As long as you don't keep hard coding them, it's a win, in my opinion. So just very quickly, some tips. This one should be obvious. Don't do it, not even for testing. Never hard code your credentials. Now the other one here, there's a Python project called .env. It helps you put them into Python.in helps you put them into an environment variable file and loads them in. So putting them in a .env file can be great. It centralizes it. You can protect it with your .git ignore as long as you know it's there. And then you can use a project like Python.env to load them into your local memory and use them. And then you'd never have to hard code them into your source code. So that's a cool thing. I have a whole video on how to do this, but it's more aimed at beginners, so probably not anyone here. But if you do want to check it out, it's on the Git Guardian YouTube channel. And the other one is that I just really like to stress this. Use whatever you're going to use, but actually use it. So maybe that's Vault, where you're auto-rotating, it's dynamic, you have a secret server, you need 3 people to manage it. But maybe that's, if you're in a company of 400 people, you should be doing that. That's absolutely what you're doing. Maybe if you're a little bit smaller, maybe using other secrets managers, a little bit down the crowd, when your cloud infrastructure will have some features that they can use. And if it's just a small group, then you can encrypt them with certain projects and store them in Git if you want to. Nearly everyone will tell you this is a bad idea, and it kind of is. It centralizes your secrets, gives you a single point of failure. There's lots of reasons why it's bad, but if it means you're going to encrypt them, it means you're going to do something, then just do that. Automated secrets detection. I work for a vendor. We got fancy tools, but there's also open source tools. And if you don't trust me, there's more open source tools there. Use Git hooks. Rotate your secrets regularly and have a policy, so then you at least know how to do it. Limit your privileges. If an API key only needs to retrieve data, make sure you set it so it can only retrieve data. Don't publish admin keys and whitelist your services. So I'm out of time, so I won't go any further, but I do just want to have a quick look at the experiment that I made. So here I said this is the key that we published. And if we look here, we have more. We have 13 times that key's tried to be exploited since I've been talking. So if you look at the timestamp here, these are the IP addresses of the attackers. This is what they've been trying to do, and this is basically how they're trying to find it. So TruffleHog, for example, is an open source tool. So leaking a secret in public repository, bots are looking for this. It's going to be found. So it is a big problem. And with that, I'm out of time. If you want to look more into the reports, the State of Secret Sprawl is there, and that one's a model on how to manage secrets if you're interested. And thank you very much for listening.
Thank you, Mac. That was amazing talk. We have plenty of questions. I'll try to be very quickly. The first one is, have you notified the user or used all the secret discovery?
Yeah, we try. So in the commit metadata, there is an email address there. Now, it can be a no reply email address. It's configured locally. If that email address is there and we find a secret and we validate it, we will send them an email from GitGuardian and say, hey, you've leaked a secret publicly. But we can't do it for everything because some secrets we just can't validate. And we don't have enough confidence that it's not a false positive, and we don't want to spam people. And some secrets, and some people just don't have email addresses. So we make an attempt. I think we were able to notify probably about 30% of what we found of that 10 million.
Questions keep coming, so I'll be very quick. Is there any convenient way to scan your own code base for secret leaks? It's not on GitHub, this one, but it's on GitLab and has millions integration.
Yeah, there's lots of ways to scan it. So there's open source tools, if that's appropriate for you. TruffleHog, GitLeaks, GitGuardian, the vendor that I work for. We are completely free for anyone with less than 25 developers. We integrate into GitLab, and so we can do a historical scan and uncover secrets. We also have an open source tool called GG Shield. So we can definitely do it, but if you don't trust me and you want to use open source tools, there's plenty available that will connect in there. It's a little bit harder. With GitLab, you can put it in the pipelines and things like that. So there's lots of ways to do it, but yeah.
Loving the talk, kudos. Do you typically look for specific credentials, for example, AWS, GCP, or also for general custom password?
So we do both. So something like an AWS credential is prefixed, a certain amount of characters, so easy for us to find. So we can cast a much wider net, and then we can validate it. So it doesn't matter if we get lots of false positives in our initial scan, we can validate it. And then we also do generic secrets. So, general high entropy strings, this is really challenging because a high entropy string has about a 5% chance of being a secret, and the other ones will be like a unique identifier. So what we do is we find all the high entropy strings, and then we will search through the code automatically to try and find out how much references I can find to if this is a secret or something of a test. But with generic secrets, because we can't validate them, and it could be like a test credential or something, then we get some false positives. But we try it, it's much more of a challenge because we have to do a lot of post-validation to try and figure out what it is automatically.
I'm going to ask you a couple of those very quickly, and I'm afraid this is going to be the last one. Does Squash on merge prevent the secrets being exposed? And the other one is there any way to clean the Git history post-incident, or some suggestion to prevent this?
Okay, yep. So Git Squash, Git is very tricky. Lots of stuff with Git is reversible. So Git Squash is reversible. You have to do a garbage collection to be able to make sure that that's actually gone. So I never recommend doing that. The reason is because you can't be sure it's gone, and also because it's bad policy, and also because history's there for a reason, right? And we should maintain our history. So if we go back, we can see why we made certain decisions in areas. Getting rid of your history limits you in other ways. So it's better to do it. Now with the cleaning the history, if a secret makes it into your repository, there's no other solution but to revoke that secret. You can try and hide it, but you have no idea where it is. You don't know whose machines it's on. You can clean history. I have videos on this as well. There's a tool called BFG Repo Cleaner, I think. There's some other tools as well that you can actually go in and pick out your secrets. But if you do leak a secret, please just invalidate the secret, issue a new one. If you have to tell someone at work that you've done it, it's forgivable. But if that secret will haunt you, and just like how these all work, the secrets that were scraped from GitHub, they were all bots that found my credential. But I'm going to get a peak of activity for the rest of the day, and then there'll be nothing. And then in 2 weeks, 3 weeks, or a month, I'll get another peak. That's because that credential has been sold on the dark web. People capture them, they sell them, they'll sell 1,000 valid AWS credentials, and then another threat actor group will try and exploit them. And maybe they'll squash it down to certain companies and areas like that. So if it leaks into your Git, even if you haven't got any notifications now, I mean, you just never know where that secret's going to end up, and it will end up somewhere.
Brilliant.
Thank you.
I'm afraid that's it. Thank you so very much, Mac, for this talk.